Welcome to ACE Engineering Academy online platform, and we are here to discuss our ISRO series. And in this series, this is the second day for this ISRO series, and we are here to discuss this data structure part over here. Okay, so ISRO here in this case is before I begin this entire session for the data structure, I just want to show a little clip of one of the historic event occur last week, and we have all witnessed that particular event. So I just want to show that little clip related with this. So this was the event I was talking about, that the launching for this Chandrayaan, and okay. So we have all witnessed this particular event, and I personally, when I saw this video, I want to watch this video again and again, and somehow, somewhere, I just also want to be part of this one of the very prestigious organization that is called as ISRO. So the journey started, and you can also start your journey for this Indians ISRO. And one of the notification is already out, and I hope that you have already filled the form for computer science scientist, engineer, computer science, and here they are offering, there are total 47 posts is available for this. This I think already done. This notification is already out, and now I think the is already over also. So now we are ready for this discussion, and here for this computer science there are various different subjects are there, and one of the important subject is your data structure. So here in this case, in today's session we are going to discuss about the data structure part. Started with this PYQ weightage, and these are the some weightage of the previous year, 2013. There are 4 questions out of it, and here in this particular section we'll just see the weightage part, and then we'll see that what are the different syllabus there is for a data structure. We'll also see one weightage analysis. I'll also present you the weightage, that how was the paper 2020 paper was distributed in terms of different section. So here this is the number of questions from this particular topic. So 4, 6, 5, 5. In 2017 suddenly there were 10 questions, then 6, 6 and 8. Okay, so 8 questions asked. Around last time when the ISRO was conducted the examination, 10% weightage was given to the data structure over here. Previously you will find very less number of questions, and the reason is that there is one more section for this data structure which is called as programming part. So if you combine the programming and data structure, then you will find that there is a lot of question asked from this particular topic. Maybe the weightage may be higher than 10%, but considering the previous examination, 10% weightage is a good weightage, you can say. So this is the PYQ weightage starting from 2013 to 2020. Now, syllabus wise, quite simple syllabus, no complication over here. But only thing that how much deep we need to go and to prepare this. So we have two sections in the data structure. We have linear data structure, that is array, stack, queue and linked list, and non-linear data structure comprised of tree, binary search tree and heaps, binary heaps also. That is also binary heaps. So two sections are there only, and data structure linear and non-linear, and in this two section your syllabus is divided. Examination divide the syllabus in only, generally data structure syllabus are this simple two part, linear and non-linear. There are other advanced data structures, the Fibonacci heap, and then red black tree, the B and B plus tree, which is not included in data structure. But as an index, we need to study preparing of the index structure for the large database management system. We need to study B and B plus tree. Apart from that, red black tree and then splay tree and then all the advanced data structure we do not have in our syllabus. Now this is, I want to show you this entire the weightage of this particular year, which is 2020. Okay, there is small mistake. Okay, 2020 analysis, the last time when it was conducted, 2020 it was conducted. Okay, just give me 1 minute. I'll just highlight this particular part. Okay, so this is 2020 it was conducted, not 22. 22 we had never this. Okay. So 2020 it was conducted, and in that you can see the different weightages. 10% means totally around 8 questions. The algorithm 9, programming is again 9%. Comparator and 6%, network 6%, organization was focused much, in that case 15%, database management less weightage, digital logic 9% quotient, mathematics was a very small part, 2 and 2 engineering mathematics, discrete mathematics, which is around 4%, operating system, lot of quotient from operating system, and then software engineering there was quotient, and theory of computation 8%. So these are the different distribution. What we are discussing here is the data structure, and that distribution is around 10% of the weightage from this particular topic. That is this. Okay, so that is the weightage analysis for this previous. What you can say with this analysis, I can say that the average value is not differing much. You can say that all sections are covered in a very comprehensive manner. Like that, maybe some cases you can say that CO was stressed much and operating system was stressed too much over there. Rest of the time, you know, the variation is between 5 to 10%, and rest of the everything is falling in that. Except what I believe is this two section, the mathematics part, which is very less. I find it very less in this 2020 paper. And overall, also I believe that in ISRO. The paper weightage of mathematics is less. Okay, so now this is something about this ISRO structure, the syllabus part we have seen, and this particular part also we have seen that the analysis part and the different years how many question has been asked. Now we can move forward over here, and we can do some, we can see some question from the PYQ or previous year question, and let's try to attempt them and see the level of the question in the ISRO examination. So this is one of the, I tried to cover all different topics, and you'll also able to understand the level of the question asked in the ISRO examination. This is one of the question. The one dimensional array has indices from 1 to 75. Each element is a string and take up 3 memory words. Okay, 3 memory words. The array stored in the location 1120 decimal. The starting address of A49 is, okay, so A49. So now these are the common calculation, common thing that we do always in the array is the calculation of the address, and we know the formula is present for this calculation: base address plus I minus lower bound for one dimension array into, you can say, size or occupied, how much memory element it is occupying. Now this is called the starting location of the array, that is the base address, so that is 1120 plus I value is this index value, the array I want to calculate 49, So that is 49 minus lower bound. Now the indices has starting from 1 to 75. Okay. So in this case, this 1 is called here as the lower bound, and this 75 is called here in this case as upper bound. So 49 minus 1, and here the each element is a string and it takes up 3 memory words. So I assumed here in this case is 3. Sometimes they mention the byte, but here it is not mentioned. Okay, so let's solve this small 1120 plus 48 into 3, and that is equal to 1120 plus 24 14, and that is equal to here in this case is 44 1120. Okay, 1120, and here is equal to 4 6 1 to 1264. Okay, 1264. Okay, 1264, and here in this case is the starting address of A49. Okay, so the answer is it should be 1264, and I think that goes here in this case is option C here. 1264 is the answer for this question. Quite simple and very basic, very basic question. And this whosoever prepare for this competitive examination is definitely aware of this particular situation and the formula over here. Okay, 1264, answer is C in this case. Let's move to the next question over here. Let's see. It says that 2013. Let A is 1 to 8, minus 5 to 5, minus 10 to 5 with a 3-dimensional array. How many elements are there in the array? Okay. So now here this is not a very conventional way of writing the 3-dimensional array, but I'll say that if I just write it for you in this way, 5 to 5, and in this case is minus 10 to 5. Okay. Now these are the dimension here, but see, don't expect always that the syntax will be always same. The way we used to write array, the same way we are going to write in every problem, or you will get the problem with that. It won't happen. Now here in this case, we know that this particular part is called as the column. Okay, this particular part is, I refer, generally there is no standard term, I refer them as the frame. Okay, this is the frame. This particular part is the row part. Okay, row part, and this particular part is the column part. Okay, so now I can say here that there are 8 frames are available. Here, how many rows are there? So now we have a very simple formula, upper bound minus lower bound plus 1. Okay, this is the formula, and this is, I find this formula very handy in many situations. So here it has become 5 minus 5 and plus 1, that is there are total 11 rows are there. 8 frames, 11 rows, and here this one, this calculation is for this. For this one we have upper bound 5 minus 10, and then again plus 1, and that is equal to in this case is 16. Okay, 5 minus this is 15, upper bound minus lower bound plus 1, that is equal to 16 here in this case. So now the total number of element that is comprised of is nothing but 8 frames with 11 rows and 16 columns. And that is here in this case is 8 into 1, 160 and 176. Okay, so I'm getting 1408. 1408 elements are present over there, and that here again goes with the option here in this case is B. Okay, now you 2 questions we have done. I'll solve more question, then we'll comment about the standard and other things. But answer here in this case is there are 1408 elements are present over there. Okay, moving to the next question is this. Okay, so now you can also go ahead and attempt all this question. Now 5 items A, B, C, D, E are pushed into a stack one after another starting from A. The stack is followed 4 times and each element is inserted into a queue. Then 2 elements are deleted from the queue and pushed back on the stack. Now one item is popped off the stack, the popped item is, okay. So now we have the entire concept of here in this case is push and pop, okay. Now questions are, you will find that there are very relatively very simple questions are there, and like basic operation that we perform over here. So let's go back here in this 5 items A, B, C, D, I are pushed into a stack. Now we know that in the, and one after another. So now we know that if 5 items are pushed, A, B, C, D, and finally you will get E. A, B, C, D, E. One after another starting from it. The stack is popped 4 times and each element is inserted into the queue. So now suppose we have a queue. And let's assume here that in this case, this is the front element. Now elements are popped. The stack is popped 4 times. Now pop 4 times, E is gone, then D is gone, and then C is gone, and then B is gone. Okay, and let me erase this thing from this part. E is gone, D is also gone, C and B is gone, and A is available over here. A is available. Okay, so now what? Then 2 elements are deleted from the queue and pushed back into the stack. So in this particular case, when you delete the first element, now the first in, first out. And this principle is what? Last in, first out. This is last in, first out data structure. And this data structure is first in, first out data structure. Okay, so in this case, E will be first inserted, so E will be gone and E will be pushed here. And 2 elements, so next element is D. D is gone from here and pushed back over here. Now one item is popped from the stack, the popped item is. So now in this case, this element which is present in the top of the stack, okay, the element which is present in the top of the stack is D. And if you feel here that answer will be in this case is D. A, B, C, D options are aligned with this indexes, A, B, C, D only and this. So A, B, C, D, E is pushed, then stack is popped 4 times. So E, D, C, B is popped and pushed into the stack. Then 2 elements are deleted from the queue and pushed back into the stack. So that element is E and D only, so that is pushed. And now one item is popped from the stack, the popped item is, and in this case the popped item is coming out, in this case is D. So now you can see that the basic fundamental understanding is required, and I am trying to, I cannot reach to all of them, but I'll try to reach, all the different topics, whatever comes in the sequence. Okay, so let's see. Let's move from this particular part. Now, the next question is also a very interesting thing that you encounter is this, that it is a GATE 2007 question. It's a 2-mark question and it's a ISRO 2016 question, and question number was 27 into this. Now see here, what is happening is that the direct question is taken from a GATE and given into the ISRO. Okay, that is one of the example, and there are plenty such examples are present where the question directly taken from the GATE paper, GATE PYQ, and given in one of the paper, maybe in this case is 2016. Now what does it say that? And it's not only one example, there are many such instances are there where the questions are directly taken from GATE. So if you have prepared the GATE examination, if you have solved the PYQ for the GATE question you have solved, then you stand a very good chance in this ISRO examination. You can expect at least, I believe that 10%, at least 7 to 8 questions will be definitely, when you see them, you can directly tick them and go forward to other question which required a solution. But again, just read it properly. Maybe copied and you thought that this is the answer A, B, C, D, maybe option maybe here and there. So, just be careful. There you will find such situations where question is directly taken from the GATE one, and like this is one of the instances. It says that the postfix expression with a single digit operand is evaluated using stack 8, 2, 3, then this 2, 3, and then 5, 1, and then this. Note that this is an exponentation. This cap is an exponentation operator. The top two operator of the stack after first star is evaluated. The first star is evaluated means over here. Okay. So let's use the stack, and what is this? The evaluation. This is one of the application of the stack. Evaluation of postfix expression. Okay, so this is what we need to do here. Now this is the expression I have written over here, and assume that this is a stack. Okay, assume here that this is the stack. Now let's see, 8, 2 and 3, 8 and 8 is the number, then 8, then 2 comes, we push, then 3 comes, then 8, 2 and 3, we push it. Now exponentation comes, and in this case exponentation is coming. Now just remember the only logic here, and here 3 to the power 2 and 2 to the power 3 both are different. 3 to the power 2 is 9 and 2 to the power 3 is 8. So you have to understand the top here when you are evaluating the postfix expression. For the postfix expression, top is for postfix. Okay, top is your second number of operand. Top is your second operand. So now there are two operands. For binary we have two operands. So this is 2 and this is 1 and this is 2 for binary. Now it will be 8 and this is number 1 and this is number 2. So you will write 1 exponentation 2 like this. This is number 1 operand and this is second number. So you'll write 2 to the power of 3 and that is equal to, in this case, is 8. So this value will become 8. Then comes division. Here you will not find any difference. 8 divided by 8, that is equal to 1. Then comes 2. So 2, what will do? Push. Then comes 3. 1, 2 and 3. Not look like 3. We'll change it. Now, then comes your multiplication. Now here also order does not matter. 1 and this will become 2 multiplied by 3. Though I write 3 multiplied by 2 doesn't matter, but later you will find that in this minus it matters, some cases division it matters, exponentation it matters. Okay, so 1 and 6. Now comes the multiplication. Okay, and what is my question over here? My question over here is that top two element of the stack after first multiplication is evaluated R. Okay, so when the first multiplication is over evaluated, the top two content is 6 and 1, and here we can go with that answer. In this case is A. Okay, so 6 and 1 is the answer for 6 and 1 is the answer for this. A is the answer for this question. Right. So let's move forward here. We have solved like 4 or 5 questions we have solved, and we are cruising. We are just moving ahead in a good manner, good pace, so that we can cover a lot of questions and utilize our entire time in best possible manner. Okay. So let's move ahead now. So next is this particular question from 2017, recent you can say, because 20 and 17. Which of the following permutation can be obtained in same order using a stack, assuming that input is sequence is 5, 6, 7, 8 and 9. Okay. So permutation. Okay. So one of the application, like here just now we have seen evaluation of expression, application of stack. Okay. So what are the application of stack, and generally what we need to cover? So application, one of the application here in this case is called as the recursion part. The second application here is the evaluation of expression. So evaluation of expression and everything about expression. And the next thing is that we have is the permutation generator. So some amount of permutation can be generated, some, not all, permutation generator. So that is the 3 application. So just now what we have seen, recursion we haven't solved any question, maybe moving forward we may have. Expression we have done and permutation generator. So let's come here. Now what is the idea that the element will come in a sequence, 5, 6, 7, 8, 9 in that order. So element can come 5, 6, 7, 8 and 9, this is the order, and but you can pop and print anytime, that is the whole idea. Now understand that if the first alphabet, suppose I consider option 1, most of you are comfortable with the idea, most of you may be not very familiar, then understand that the first alphabet that you are printing is 7. Then 7 is possible when you put 5 and 6 in the stack. Okay, you understand, 5 comes you push, 6 comes you push, 7 comes you push and pop, to 7 will come. Now, just only a small thing that if you put the value 7, then you are putting 5 and 6. Now 5 and 6 order is 5 and 6, but when you put into the stack, the order of popping will become 6 and 5. If you are putting here first value as 7, that means 5 and 6 are still holding temporarily in a stack, and in that stack when you are going to pop the value, okay, when the stack you are going to perform the pop operation, they will be in the reverse order. Okay, they will come as 6 and then 5, right? So order here it will be 6 and 5, but here order is 5 and 6. So then you say, why not about 8 and 9? So understand that 7, 8 push and pop, 9 push and pop, but when you come to popping the 5 and 6, the order will be always in the reverse, that will be 6 and 5. This cannot be your answer. With the similar logic, 5 comes, I do push and pop, like here in this case is 5 comes, I'll perform push of 5 and then I pop it, so 5 is printed. The next value here in this case is 9. Okay, the next value for printing 9, what you need to do, 6, 7, 8 and 9, these elements should be put into the stack. Okay, so I need to put the element 6, 7, 8 and then 9. Finally you can say, okay, go ahead and print 9 here. So push, 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 push. So we perform this push operation on this data structure, which is one of the fundamental operations of this stack. So 6, 7, 8 and 9 is pushed, and now what we are going to do, we are going to pop 9. But again, if the first element is 9, the order rest of the element will be in the reverse order. So 9, 8, 7, 6. What is the ordering here? 9, 6, 7, 8. So this cannot be also the permutation here. Now I am coming to the correct answer. 7 is there and then the order is 6 and 5. So just now I told you, like here I can give you a sequence for this. I can say push 5, then I can say push 6, then I can say push 7, then I'll say pop, so 7 will be popped. Then what 8 comes, so I'll say what push 8 and pop immediately. Then I'll say push 9 and then pop immediately. So push 8 and 9. Then what? You have to perform the pop operation. Pop 8 and 9 is done. Okay. So you say pop and one more time pop. Now look at here. 7 is popped, 8 push and pop, 8, 9 push and pop, 9. Now what we are left here in this case, a stack consists of 5 and 6. So 5 is there and 6 is there. First 5 will be go for 6. The next will go for 5. This is very much possible and that is the correct answer for this. C is the correct answer for this particular question. Now this is not a gate question. That also be, let's be very clear with that. So do not be very optimistic about that you are going to get plenty of gate question. Don't think in this way. Just have a clear mindset. If the question comes, we'll attempt it. Otherwise, if the question does not fall or does not belongs to the one of the PYQ previous year gate question, then we won't. Then the meaning is that do not expect much. Okay, if you expect much, then your entire preparation will be focused only for the gate PYQs only. Don't do that. Learn the concept, complete the syllabus, go for the examination. And it's not one of the very difficult examination that you have. Paper standard will be below gate standard. Okay, that also one of the correct evaluation, that the standard of the ISRO paper is not as on par with gate paper. Next question. Now this is the question. You see that pattern is there that I am following. That we started with few questions with array, then linear data structure, then a few questions related to stack and queue that we have done, and then we are coming to the linked list. And here the time required to search an element of the linked list of length n is. Now here the question is about from the time complexity. Now here generally what happens is that sometimes the order doesn't match. Like here there is a lot of this dependencies are there. Like if you talk about algorithm and the data structure, these two subjects are highly interlinked actually. Highly interlinked in a sense that you cannot decide the order. Means you cannot say that algorithm first and then data structure, because algorithm required data structure. Data structure also required algorithm. So the moment you are completed with everything, like you completed the data structure and algorithm, then finally few topics you can understand in a better way. And one of those topics are the cost of the operation, the time complexity of operation on the data structure. Operation on data structure. So this thing you can understand better only if the things are complete. The time required to search an element. So now in this case is searching, linked list searching is only one way, and that is here in this case is linear search. Linear search. That is the only search which is possible for linked list. Binary search directly goes to the middle index of the given list or array, but in linked list it is not possible. If you're not maintaining the separate indexing, then it is not possible to directly go to the middle element. So here it is not possible. We need to do the linear search, and linear search is order of n. Okay. So I'll just small correction, n square, and this is equal to n. So answer for this particular question here in this case is n, and we'll go with B. Okay. B here. Then some of you which are aware of it, then you might argue that why not this in this cases. Okay, so correction. Okay, so now this. Okay, so order of n is the correct answer. Log n order of 1 not possible, and this is theta of n square. So exact time it is talking about, no, that is also not the correct answer. So answer is n. Let's move to the next question from this. Okay. Which of the following operation is performed more efficiently by a doubly linked list than the linear linked list? So which operation is performed more efficiently by on a doubly linked list than by a linear linked list? So which operation we can perform? So let's say that you want to delete a node whose location is given. So understand here, this is something that I need to describe you graphically, that if there is a single linked list, and this question was also present this year GATE also, that is also present this year, that suppose you want to delete a particular node. Deletion, what is the issue with the deletion is this. You want to delete a node and whose location is also, this pointer is, location means a pointer is given to you. You know the address, suppose you know that this address is 100 and this address is 200 and this address is 300, and suppose this particular address is 400. Okay, now this is the pointer. Suppose a pointer is given to you, then you want to delete this. Now here you want to delete. The problem here in this case is that linked list cannot go backward. Okay. Now here I need to, if I want to delete, I want to make this link to this and this to be deleted. Okay. So overall this is the thing that we need to do, and we need to just discard this particular node, that this will be gone. This will be gone. Right. Now the problem here in this case is that if I do this thing, I need to go backward. So we cannot go backward over here. But one of the trick that is required, that is we generally use, is this, that if the pointer is given to you, don't delete this node. So one of the tricks that we use here in this case is, and don't fall with that also, because copy the next node. copy the value of next node. And delete the next node. Means you copy whatever the value, suppose this is 4 and suppose this is 3. So you copy 4 over 3. Okay, you copy this over here and delete the next node. Okay. So now this is one of the trick, and that's why we generally say that okay, we can delete the next node, so we can do this thing in order of one time. The problem is this entire trick part is not going to work for the last node actually. This is not going to work for the last node. So overall, if you say that what is the complexity, so even in one case also you are taking order of n time, then we can say order of n time. So deletion whose location is given, in this case linked list till n, but if it is a doubly linked list, I can do in order of one time. Searching, both required order of n, maximum n, and order of n time. Searching. Inserting a node after whose location is given, in that case also location is given, then order of 1. After, okay, backward not, order of 1 and order of 1. Traversing the list and process each node, and that is order of n and order of n. Okay. So here only thing that can give you better result in terms of doubly linked list is deletion. Because in doubly linked list what will happen, I can go backward. Okay, I can go always, there is a 2 pointer, double pointer, forward as well as backward. So that way deletion is not an issue. For single linked list trick is there, but the problem is that if you're deleting the last node, that thing is not going to work. Okay, that thing is not going to work, and that's why we say that here in this cases answer is in this case is A. So that is the answer here, that will go here in this cases. Next, again a linked list and this operation performed on the linked list. So what I find here that not only in the GATE examination, but in ISRO examination the pattern follows. Okay, they are not concerned about the operation on the array, linear data structure I am talking about. They are not concerned about the operation on stack. They are not concerned about the operation on linked list. They are more concerned when the question related with time complexity comes. The question begins from linked list, from the linear data structure. Array, stack, queue, they don't bother. Means there are very less questions from there. Stack and queue, most of the time their operations are very limited. But here in the linked list there are plenty of operations are possible. So linked list, from the linked list onwards, linked list, then tree, then BST, then heap. Linked list binary search tree, AVL tree. Onwards, the questions start related with complexities. So from linked list onwards, you have to be very careful in terms of also, when you're studying, you must know the cost of each operation. That must be covered when you are preparing for a competitive examination for data structure. Let's come to this. Consider a single linked list where F and L are the pointer to the first and the last node respectively. The first node and the last element respectively, first and last. The item for the performing which of the given operation depends upon the length of the linked list. So now single linked list is there, and it says that which operation depends upon the length. Length means that length generally what we consider as the size as n. Now you must be aware that size is n is the input size or n is the array size. Delete the first element of the node. Deletion of the first element doesn't depend upon the length of the list. You can simply come, you can follow the pointer, you can delete this and you can make this as the first pointer or head pointer. Interchange first two element of the list. Now if you want to interchange one and this second element, do you really need to traverse the list? Or you need to go to the depending upon the size of the list? No. I can simply go and swap the value and I don't need to traverse. Delete the last element of the list. When you want to delete this L, then you will say, okay, I will follow this and I'll delete this value L from this. I'll just free it. The problem is that linked list should be null terminated. If you're deleting this node, this last value should be assigned to null. Can you move backward from this node? From this node, can you move backward? Answer is no, you cannot move backward, right? So here what you need to do, you have to first reach to the node whose next is the last node. You have to stop here, okay? Next to next is null, okay? Next is not null. Next to next is null. You have to stop here, and then you can simply delete this and you can assign this to null. Add an element at the end of the list. You want to add it, create a new node, join this link, and null pointer, and update the value of L. So not depending upon the length. Now, what is this? Deleting the last element of the list. That answer in this case is C is the answer for this question, right? Okay, so that is something about this question. Okay, now one question here: the full binary tree with n leaves contain. Okay, so we try to cover as many as things possible, but again our duration is only 1 hour. So let's see. Full binary tree with n leaves contain. Now in the full binary tree, this is the structure of the full binary tree. Okay, this is the structure of the full binary. Every level full. Okay, every level full. This. Okay, I'll go one more level for you so that you'll have clear. Now, here there is a very important relationship. This is called the full binary tree. Now here the relation is that the leaf node is in the full binary tree, leaf node is in this case is n. Okay, if leaf node is n, then internal node is always n minus 1. Okay, this is the relation, internal node. Okay, leaf node is n, leaf node is always contain n minus 1 internal node, and that is equal to in this case is 2n minus 1. So total number of node here in this case is 2n minus 1 node. Okay. So here this is the relationship for the full binary tree. You can check any small binary tree also. Even if I get rid of this here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 leaves are there, and 1, 2, 3, 4, 5, 6, 7 internal nodes are there. So total is 2n minus 1. Okay. Fine. So one more question, then we'll finally wrap up this session. Of the following, which of the best approximate the ratio, different question, different type ratio of the number of non-terminal node, means non-terminal means internal node, non-terminal node. So non-terminal means internal node. And total number of node, ratio of non-terminal node and total number of node. I'm really expecting a better language over here, but let's see that approximate the ratio of the non-terminal node and in the total number of node in a complete k-array tree. Now we know that complete k-array tree in this particular case, n is there, of depth n, okay, tree of depth n in this cases. So k-array tree we has having very interesting property that if I say that L is the leaf, L is the number of leaves, and n is the number of let's say internal node, n is the number of internal node, then it is having total number of node as total number of node as what is this? L plus n, leaf plus internal node, and it is having very interesting property that L is equal to n times k minus 1 plus 1. This is one of the very fundamental relationship or between leaves and the internal node. Maybe you have written in a different variable. Maybe you have learned this thing in terms of I. This is also true. Now if I just replace it and this L value, then it will become nk minus n, okay, I just open this one, plus 1, and then plus n. Okay, this is L I have replaced with this value. Okay, this is the relationship, and this is the, okay, don't look at this, this is the relationship part. So this, and that gives you in this case is nk plus 1, that is the total number of node. So what it is saying, the ratio of non-terminal node n divided by what it is becoming, nk plus 1. Okay, and approximately I can say n divided by nk, and I can take it out, and approximately I can say 1 by k. So in this case, answer here, I'll go here in this case is 1 by k, and it is one of the very good question asked from this particular topic. Okay, so look at here once, if you're still confused with this, the question is the ratio of internal node to the total number of node, and here we are assuming L is the leaf node, N is the number of internal node, then total number of L plus N. Now we know that if it is a k-array tree, complete k-array tree, 0 or k children, we know that they are related quantity L is equal to internal node k minus 1 plus 1. So within the total number, replace this value of L, nk minus n plus 1. I just open this n. Cancelled out, and that is coming as nk. So now your internal node is n, and total number of node is approximately nk plus 1. And because the question is about approximate, best approximation, and that is in this case is 1 by k. Okay, so that leaves us with this end of our session, and I'll just talk about the preparatory tool that is available with ACE Online. Okay, so with ACE Online, there are a lot of preparatory materials are there that you have a self-paced program that is available for almost every possible courses. Okay, IES to in this case is your state PSC, and then you can go for GATE, and all different courses are available over there, including your GATE as well. Okay, so that is one of the best platform, best online platform with different activities and different in this case is tools for preparation. Like you can say the self-assessment test is there, and then ask an expert is one of the most beautiful concepts where you can clarify your doubt anytime. Then we have the quick revision course that you can basically use for this preparation of this ISRO examination. Quick revision is it's not a very lengthy version, means like our main course are a length of around 500 to 600 hours. This consists of only 250 hours, and you can have 120 days duration of it, and that will more than enough for preparing for this examination, which is ISRO. And detailed is everything, is not that something is missing. Because you want revision, you can definitely go for this this quick revision course, pre-recorded course. Definitely the previous year questions is also available. That is also in the form of what as a video. All question and answers are there. So if you are already not interested in going through the concept, you want more and more practice, so you can go one after another in this questions, and you can attempt it, and you can directly look at the solution, and that is also consists of GATE plus ISRO. Okay, so that is it. That these are the different available courses present over there, and ISRO handbook over there that is comprised of the previous year question, subject wise and chapter wise, 2007 to up to 2020. Okay. Now, just word of caution and just small advice. What I find here that some questions are truly ambiguous in the nature in ISRO. I personally felt that the data could have been more clarified, or the data could have been given in more, or the statement could be more clear. So I really find that few questions are really ambiguous, and you can expect those ambiguous questions in the coming examination also. Why it is so, purposely or unintentionally there are errors or what, but something is missing in some questions. Now when this situation will come, my advice is to skip all this question and go ahead and try to attempt as many as question possible over there. Last thing is that the missile man, this Mr. Kalam sir. The success in your mission, you must have a single-minded devotion to your goal. Okay, so this is one of the great words by the great scientist ever produced by ISRO, and in this case we can say that he is the one man that we have to always look forward. He is the only man who can define the success in best possible manner, and his own word is saying that if you want to get succeed in your life, then you must have a single-minded goal. Okay, so nothing else, straightforward statement that you need to focus on your goal, and your focus should not be anywhere else. On that particular note, wishing you all the best of luck, and prepare well and do well in the ISRO examination. And in next few days, again the ISRO next series in the series will continue, and next subject will be available for this detailed discussion, whatever we have done today. Okay, so that's all for today's session. Thank you very much.